me. So I hope you all are having a great day, and I missed seeing everybody in class when I get all the emails that people are going to be out. It makes me sad. So I hope you guys are all doing well. And today this video is going to go over section 5.5, and then I'll do another one that goes over 5.6. So I think it should be pretty straightforward. So let's go ahead and get started. All right, let me go ahead and share my screen here. All right, here we go. So we're going to jump right into the notes, and we're going to move on from talking about just triangles specifically, and the centers of triangles is where I was going with circles. And we're actually going to talk about some other properties of triangles. So the first property we're going to talk about is actually pretty straightforward once you think about it. So this property, we're going to start with example number 1. Again, we're in section 5.5, and we're going to start off with an example. So the example says, mark the largest angle, longest side, smallest angle, and shortest side of the triangle shown. What do you notice? Okay, so it says mark the largest angle and longest side. So I'm going to mark the largest angle with red. And when I look here, the largest angle appears to be this one right here. Right, so that's the largest angle. It might be an obtuse angle. I think it might be an obtuse angle. So that's the largest angle. Largest angle. Okay, and then I want to mark the longest side. So this right here, I've got 3 sides. This one is the longest side. Okay, and then on the other side, I want to mark the smallest angle. So if I look here at my smallest angle, this angle over here on the right-hand side appears to be my smallest angle. Right, and then the shortest side, it's definitely this guy over here. He's shortest side. Okay, and so what I notice when I mark this is that the largest angle is across from the longest side. See how they're across from each other? And the smallest angle is across from the smallest side. All right, so the longest side and the largest angle are opposite each other. Shocking, right? They're opposite each other. And the shortest side and the smallest angle are also opposite each other. And guess what? If you look at any triangle, so we'll just kind of pick on this triangle over here. If I look at this triangle, the longest side is over here. I can just look at my numbers, right? And guess what? The largest angle, the one that's the biggest out of the 3, is across from it. It's opposite it. So not a coincidence. In fact, we actually have 2 theorems. I have to say these are probably one of the easiest theorems, theorem 5.10 and 5.11, that have to do with this relationship that the bigger the angle, the longer the side that's opposite from it, which kind of makes sense. Like, think of it in your hands. If you have a teeny tiny little angle, the side across from it's going to be really small. But if you have a really big angle, the side across that's going to be really large. So let's fill these 2 theorems in really quickly and move forward with this. So theorem 5.10 says, if one side of a triangle is longer than another side, then the angle opposite the longer side is larger. It's larger than the angle opposite the shorter side. So in this picture, side AB is greater than side BC, right? A to B is 8 and B to C is 5. So that means that you go across, angle C is greater than angle A. So it's the opposite side, right? And then 5.11 is the opposite of that. So we're going to talk about angles. So in 5.11, it says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is larger than the side opposite the smaller angle. So now we're going to look at this from the angle standpoint. Measure of angle A is bigger than the measure of angle C, right? And so that means that side BC is greater or larger than side AB. So pretty straightforward stuff, right? So let's do a quick example with this just to make sure you're comfortable with it. Actually, there's a couple examples and we'll go through it pretty fast. So here we go. We've got a boat, a long-tailed boat that leaves a dock and travels 2,500 feet to a cave, 5,000 feet to a beach, and then 6,000 feet back to the dock, as shown below. So they give you a nice picture. It's going in a triangular shape loop, right? One of the angles in the path measures 55 degrees, and one is 24 degrees. What is the angle measurement of the path made at the cave? So basically, they want you to fill in the blanks and tell which angle each of these form. What is the angle between the cave, the dock, and the beach, the angle between the dock, the beach, and the cave, and the angle between the dock, the cave, and the beach. So what are those angles? So they only give us two angles, but how can we find the third angle? Well, we always know that a triangle adds up to 180 degrees, right? So a triangle always adds up to 180 degrees, and we have 55 and 24 degrees. If we subtract those two, and I sneak a peek in my paper, I figure out that the other angle has to be 101 degree, right? 101 degrees. So it's 180 minus 79. There we go. I could have added those together and did that. All right. So these are my three angle measurements. And I just learned that there's a theorem that says that the largest angle is across from the longest side, right? The largest angle is 101 and my largest side is 6,000 feet. So that means the cave has to be at 101 degrees. Okay. The next biggest, the middle one, right, is 5,000, and across from 5,000 is the dock. So that means this has to be 55 degrees. And then my smallest angle has to be across from my smallest side. So this over here, the beach has to be 24 degrees. So pretty straightforward, right? Again, kind of check yourself here. List the sides of triangle PQR in order from shortest to longest. So if I wanted to list the sides from shortest to longest, my smallest angle is right here, angle P. So that means my shortest side would be QR, is the shortest side, right? The next, the middle angle, right, is 55. So that means that the middle side is PQ. And the largest side is the one across from the largest angle. The largest angle is 80, so the largest side is PR. Okay, so that's how we would do that. I think you guys should probably be able to figure this out. It's pretty straightforward. So we'll just let you work on that. Let me know if you do have questions about that though. And then, so pretty straightforward. Like I said, pretty easy peasy. We like that, right? All right. The other thing I wanted to talk to you about is theorem 5.12. So this one is a really important theorem. Again, tutoring some people on ACT, SAT, and this does come up on the ACT and SAT. So this is called the triangle inequality theorem. So before I even tell you what the triangle inequality theorem is, let's say that I said to you, could you please draw a triangle that has side lengths? So I'm giving you side lengths, right? It has side lengths of 3, and I have to think for a minute. 3, 3, and 7. Okay, so this is where I would tell you, like, you're on YouTube, you know, pause the video and try to draw a triangle that has side lengths of 3, 3, and 7. Okay, so if you tried to do this and you had a ruler, which I can't pull up my ruler on here, right? You had a ruler and you tried to draw something that had side lengths of 3, 3, and 7. It's obviously not going to look like this, right? 3, 3, and 7 is going to have a really long side here. And then two sides that are like really skinny like this that are 3, 3, and 7, right? So kind of, you know, play with that, see if you can figure it out. So I'm going to give you a little spoiler alert, and having a triangle with side lengths of 3, 3, and 7, if you've messed around with a little bit, is not possible. It's not possible to have a triangle that has side lengths of 3, 3, and 7. Because think about it. Even if I drew the biggest obtuse angle that I could, right? One of my angles in my triangle was 179 degrees, right? So here's my top point, and I drew this almost like a line. And this is 3, and this is 3, right? So if you're almost flattening it out completely, it's like almost 6 if you add 3 and 3 together. Is there any way that I can then connect the third side that's 7? Yeah, there's no way to do that, right? I could never, if I have a bottom length of 7 and two sides of 3 and 3, adding them together to make 6, there's no way that I could even connect them even to make like a straight line. So that's what this triangle inequality theorem talks about, is what are the possible side lengths for a triangle? Like, given 2 side lengths or 3 side lengths, is it even possible to make a triangle out of those? So the triangle inequality theorem is an important theorem because, like I said, we need to understand how to use this. It is a concept that you'll use in Algebra 2, ACT, things like that. So what it says is the sum of the lengths of any 2 sides of a triangle is always greater than the length of the third side. So if you add 2 sides together, it always has to be bigger than the third side. So that's why this fails. If I add 3 plus 3 together, it's not greater than 7. So it fails this theorem. All right, so in this picture, we have triangle ABC. So if I add side A to B plus side B to C, so if I add this plus this, it has to be, those added together have to be bigger than that side. Okay, but it's not just that you can check one set, you have to check all 3 combinations. So you have AB plus BC has to be bigger than AC. You also have that AC plus BC has to be bigger than AB. So let me say this. This would be, does this plus this, are those 2 sides added together, are those bigger than this side? All right, that's AB over there. So we've checked 2 of the 3. And then the third one is AB plus AC bigger than BC. So again, let me highlight this, is AB plus AC bigger than BC. And that one's pretty obvious, those 2 added together are bigger. So if your triangle, if you have 3 side lengths, do they meet this? Do the 2 side lengths, if you add 2 of the side lengths together, are they always bigger than the third side? Like I said, this is something that you would have to check all 3 combinations of that. So what I want to do is kind of do an example with this. So it says a triangle has one side a length of 14 and another side the length of 10. Describe the possible lengths of the third side. So when they say describe the possible lengths, they're basically asking, what can the lengths be? It's not like it could be long or short. That wouldn't be exactly what we're looking for. So I'm going to zoom out a little bit here because so we have 2 sides, right? One is 10 and one is 14. So we know those 2 side lengths. So they're asking us, okay, I'm having all kinds of trouble drawing lines lately. Not a good thing for a geometry teacher. So what can the length of my third side be? That's what I want to know, okay? Now, I did a couple scenarios for you with using a different tool. So I have side lengths of 10 and 14. These are actually measured correctly, accurately. They're to scale. So what can this third side be? Well, this is one possibility, right? My triangle would be that. What happens if I made the angle, this isn't really labeled here, but we'll say that's C down there. What if I made the angle of ABC really, really small, a tiny little acute angle? So look here, what if I made my triangle ABC and the angle ABC is really, really small? Well, then the distance between A and C could be a pretty small distance, right? So it's possible I could have a really small distance. Or what if instead of making angle ABC really small, what if I made angle ABC really big, like almost the biggest obtuse angle that I have? If I did that, then I'm going to have a side that's really large, right? So if I did that, then ABC is going to be a really big number, right? So I don't know exactly what those are. I could get out my ruler and measure it using my tool, but I can use this triangle inequality theorem to figure out what are the possibilities. Okay, so this is where you have to check all of your different options. Let me go ahead and label these as this is C, C, and C. Sorry, that was bothering me. Okay, so we just learned, right, that the triangle inequality theorem says that if I add any two sides together, they have to be larger than the other side. So let's start. If I add AB plus BC together, so let me scroll up here, A to B plus B to C, is that larger than A to C? Oh, and we don't know what A to C is yet, right? We don't know what this is, so we're going to call that X. So if I add together 10 plus 14, that has to be bigger than X, right? So 10 plus 14 is 24. And X has to be less than 24. You see how I did that? So if I add A to B plus B to C, it has to be greater than the whole distance from A to C. So A to B plus B to C, do all the math, and I know that X has to be bigger than 24. X represents the side from A to C, right? This right here represents this scenario. Basically, I can't get my angle, sorry, this scenario down here, the third bottom one is where I'm pointing to, okay? I can't have this line down here be any bigger than 24. This X has to be less than 24, right? If I get bigger than 24, then my lines get too big and it's not going to work. That's 10 plus 14 together, right? 10 plus 14 is a straight line, and that would be too big. So X has to be a little bit, that side has to be a little bit smaller than 24 in order to make a triangle, right? Okay, but I'm not quite done yet, right? I have to check the other sides. So I did AB plus BC equals AC. Now I'm going to check, what if I do AB, right? But instead of plus BC, I do plus AC. Is that greater than AB? Right? Is AB, oops, sorry. That's not right. Go back. Come on, mouse, there we go. No, there's two ACs on there. AB plus AC, is that bigger than BC? Sorry about that. How is that going to work? All right, so A to B is 10, right? A to C is what we're trying to figure out, is X. Is that bigger than 14? Is that going to work out? All right, so to do that, we got to do a little math. We would subtract 10 for both sides, and we get that X has to be bigger than 4. Okay, well, that seems reasonable, right? X has to be bigger than 4. Over here, now we're kind of talking about the smaller scenario when I have a tiny little acute angle, right? When I smush it together, I can't smush it all the way together or else I'm not going to have a triangle. What is the smallest, angle that I can make there that makes it true? So it seems like that scenario means that this A to C has to be bigger than 4. But we have one more to check, right? So let's check the third one, which is what happens if I add together BC plus AC. Is that bigger than AB? It's my third scenario. So BC is 14 and AC is X, and that has to be bigger than 10. Okay, so then for this scenario, I subtract 14 from both sides, and I get X has to be greater than -4, which seems a little weird. But now if I compare my two inequalities, I have X has to be greater than 4 and X has to be greater than -4. And if you remember your number line, like if you're thinking about a number line, X greater than 4 is closer in. This kind of invalidates this one down here, right? X has to be greater than -4 is pretty easy. So we know that X has to be greater than 4 in order for this triangle to exist. So if I want to go back to my question, describe the possible lengths of a third side of a triangle that has a side length of 14 and 10, right? That third side would have to be greater than 4 and less than 24, right? So in order to make a triangle that has side lengths of 10 and 14, the third side either has to be greater than 4, and it has to be greater than 4 and less than 24. It's not an either or, it has to be both. So pretty cool. That's a way that you can check out if your triangle, it's possible to be a triangle or not. And you can stump your friends by giving them triangles that are like 3, 3, 6.5. Is it possible to do a triangle that's 3, 3, 6.5? It's not, because you add 3 and 3 together, it's bigger than 6.5, so not possible. Anyway, so that is 5.5. Check that out and let me know if you have any questions. Take care, guys. Bye.